Okay, Assalamualaikum warahmatullahi wabarakatuh. This is a paper or a presentation on using a Maxima, a computer algebra system, for solving mass spring system, especially for the teaching of civil engineering students. So my name is Syahrul Fithry Senin and my colleagues from UiTM Pulau Pinang, Permatan Power Campus would like to present on this topic. So before we start, we just do some kind of overview of the mass spring system solutions. So this mass spring system has a lot of application in a civil engineering. And so some of the complicated problem can be modeled by this mass spring system, and the student in the civil engineering are required to understand on how to solve the system based on this model. And as I said before, there is a lot of variety of application of this system in engineering, especially in our solid mechanics subjects, where we can analyze the material behavior by using this mass spring system, whether it is with damping or undamped condition. And also we can analyze the same problem for other applications such as for the fluid mechanics, where we can also model the system by this mass spring system. So there are several components of the basic elements in this mass spring system. So the student should know how to model the given problem to the mass, springs, and also the dashboard. So each of the student has been taught on how to identify this behavior on the given problem so that they can model it to these three basic components. And usually in our teaching, we'll start the modeling by analyzing a very simple system where you can analyze a spring that is attached to a fixed wall, and you have a hanging mesh at the ends of the spring, and by doing so the spring will be elongated with certain x distance. So originally the distance of unstretched will be L plus S, but after the system is under the mesh weight, then the system will be stretched by X. And we can analyze the system whether the displacement to be a negative or positive displacement. So usually displacement we call it in engineering as amplitude. And to solve the system, we have to know the variables involved and the forces involved in that mass spring system. So as you know that the mass can be analyzed by using this equation. Weight is equal to mass times gravity. The spring mass force system we can analyze by this system of equation. Fs is a spring force inside the spring, and K will be our constant spring, the spring constant, and you have the stretch, which is S, and plus with the position of that mass, xt. And we have also the damping force, where we quantify the damping magnitude by this constant beta, and we multiply it with the velocity of that mass, which is dx over dt. So for no damping, meaning that this beta will be 0, but with damp system, this beta will be not equal to 0. Okay? And for applied external force, we have two systems which is the free vibrations, where Ft is equal to 0, or Ft can be any external force. But in this paper only, we just only discussed about the free vibration, where Ft is equal to 0. And the student also will be make them understood by using the Newton's law. This is the famous equation, and by applying all of that equilibrium, and you get the famous equation that has been used in physics fields and also in engineering fields. and this equation is subjected to initial conditions lah, especially the initial displacement and also the initial velocity, especially when the time is 0. And the problem is that when the student want to solve this problem, they have to use method that is very easy to them. So usually if they are required to use the analytical approach, where you have to use the normal calculus knowledge, they have a very lot of resistance, because the student sometimes they cannot solve the problem by these mechanics or by using the calculus. And if let's say we provide them with a numerical approach, they are also not so skillful, especially in order to produce programming codes, because they have to learn the programming skills in order to solve the equation. And due to that, we are trying to use a symbolic approach, which is using a computer algebra system, using the Maxima language. So why we use Maxima language? Because it's an open source software. It's not like Maple, we have to buy the license. The programming file also have a small file, which is less than, I think, 1 gigabyte. It's very small, and also is a very user friendly. So that's why we are choosing this Maxima programming for solving the differential equation, especially in the mass spring system. So our problem statement is that usually when the students are required to solve the differential equation for mass spring system, they have the difficulty in order to formulate the mathematical models, and also in order to find the solution. So they have also some problem about their belief on their generated solution based on analytical problem, because they have no reference whether the solution is correct or not. So this has been given also in one of the comment in the maplesoft.com. They highlight this issue when they do their differential equations. They found that when their answer doesn't match with the answer in the back of the book, and you know the book is something wrong, you don't know who to believe. So they have the problem of belief, the belief emotion. So this makes the student demotivated to solve the equation and to understand the problem for engineering. So that's why we try to do this research and this paper to provide another means on how to solve the mass spring system by using a more simple way. So this is the 4 stages of methodology. We started the work by giving them 2 differential equations, and they are required to solve that equation by using traditional approach. So when I say traditional approach, meaning that they have to use the normal calculus, where they have to use the integration or differentiation concept in order to solve this. And after that, the same group of the student will be given some briefing on the Maxima, especially the template that has been developed to the participants, and they will use the template to solve the equation by using the Maxima programming. And after that, they will understand what are their errors by comparing stage number 1 and stage number 3, and this will be giving them some kind of good findings in our result discussions after this. Okay, so the problem given to them is the free vibration undamped, where this is the question, a spring with a certain mass, with a certain length, and we have the stretch length. So the student will be given all of this information, and they have to formulate this by using a model. So before they have to use the Maxima, okay, they have to find the constant K, and this is the parameters of the problem. The key constant is 1 to 8. It's a free vibration, meaning there is no external force, and this is undamped situation. Beta is equal to 0. So by substituting the parameters to the equation, then they will get this equation that need to solve, and that equation will be subjected to this initial condition. So all of this information can be found from the questions. So now they will use Maxima to solve the problem. So this is the video problem. So we want to erase all of the variable. So maybe the previous variable that has been stored inside this program by typing kill all of the variables. Okay, and we put this $sign to suppress the output. And then I will ask the system to know what will be the dependent variables that we'll have here. So our dependent variable is our displacement x and also the time t. Okay, and again I'll put this $sign to suppress the output. And the next part is to define the equation of the motion, which is so this is the equation that I mentioned before, and it's written equation given by the problem, which is on this video demonstration. X double dot, which is can be converted to the differential equation if of our x with respect to t by 2 times, because we have double dot x, and we have to plus with this equation. And because this is a free variation, so there's no forcing outside, which is 0. And I'll put again the sign $. So you can see that the program is quite natural. There's no complicated and to solve the equation symbolically, you can use this command, ordinary differential equation for the second order function. And this the percentage sign is for asking the system to know that we want to solve the previous equation with respect to x and our t. So by doing so, we'll get the general solution of the equation. So can you see that this is a very useful, the solution is generated automatically, especially for engineers, so that they can get the solution directly without to go deeply to the basics of the mathematics. And if we want to integrate our initial conditions, so we can type this command, initial condition for the second order, and we want to solve for the previous equations, which is this general equation, and I will type the time, which is starting from 0, our displacement to be 0.2 meter, and when the time is 0, our velocity, which is the differentiation of our x with respect to t, that is equal to 0. And you can see that the solution of the problem can be obtained here. So after this, I will show you the graphical solution of this by using Maxima. Okay, the next part will show you how the student can visualize the visual of the problem. So we want to erase all of the variable. So maybe the previous variable that has been stored inside this program by typing kill all the solution of the displacement in the graphical form. Okay, never mind. I think there's a technical problem about the graph. It should be there is a graph there. So the second problem is for free vibration and damp vibrations. So the same problem, but we just put some kind of damp constant. And there's no video here, but I just give you the code itself by Maxima. So we have already the band damping, but still free vibrations. And the equation of motion will be something like this. And this is the initial condition. So by using the Maxima, we can get the solution. You can see that you can get the general solution by substituting the initial conditions, and by using this command you can get the graph, so the student can visualize the solution visually. So you may see that the amplitude will be reduced by time, and suddenly will be almost zero when t is reaching 2 seconds. So by using this, you may see that it was found that the poor student with lack of comprehension of both problems, meaning for the undamped and damped vibration, will be much more better in terms of their struggleness, because when they want to do the same problem by using manual computation, they have to recall the integrations and the integration and also the differentiation part of the calculus. In the third stage, it was found that the poor participant approach changed from the directed method to a non-directed method. So directed method meaning that they have to follow certain rules from calculus. However, by using Maxima, they will use a more non-directed method. So they will use their own way on solving the solution. And this is much more less time-consuming process, and it will be more fun to solve the problem. And they feel also that the student feel that the using Maxima will be lessen the problem of providing lengthy computation process, and they give them a better knowledge on several key principles behind the DE solutions. And this is a tally and in line with the research by Ligard and Yusuff, by highlighting that the per participant in their research will have shortened time to solve the problem. So it is a good motivation to them to learn differential equation by using math spring system. So as a conclusion is that Maxima software can be used to promote structured mechanical concept and understanding for civil engineering students, especially for the math spring system. And although this software is you can say that there's no programming skill needed, it reduces the effort required to solve the different equation, especially in the math spring system, and the student can learn and see the graphical representation of the solution. And the student feel then a very pleasure and high positive expectations by this Maxima. So I think with that, thank you. And if you have any question, you can post to any channel that you want to post a question. Thank you. Assalamualaikum.